Hello and welcome to this WATS webinar where we will be covering the test step analysis report. My name is Ola, and today Haldur, our customer success manager, is also joining us, and he will be watching the chat and questions. And you please ask any questions as we go along if you have any, and we will try to cover them. I'll just jump straight ahead. We have 30 minutes on the schedule today, so I will just go ahead and get us started, and hopefully we'll have some questions and we can answer them as well. So today's agenda is pretty simplified. I have focused deliberately on keeping the agenda limited to allow for some questions and some interaction, but if no questions comes up, I probably have something to fill the time with. So the first thing we're going to look at today is analyzing the top failure from the process heat map, which is probably the most frequently used way of using the test step analysis report. And we will look into the step details view and with focus on the workbench part of it. We have some new features in the workbench and we haven't really focused much on this part of the step details report yet. And then we're going to look at a little bit more complex TSA features, such as combining steps from different processes, utilizing the entire test step analysis report, not only the step details. And then if we have time, we will do a questions and answers round in the end, but also feel free to raise hand or type a question in the chat as well. So from here, I'm going to skip into WATS, and this is the WATS start page. You're probably familiar with this. I've had a look at the registered attendees today, and most of you are familiar names and have probably used this report before, but we also have some brand new customers and also some non-customers joining us today. So from my start page, I have predefined process heat map, which is called Test Step Analysis Webinar, which will show up here in my shortcuts. So I'll just use this to open the process heat map. And for anyone new, the process heat map is one of the ways in WATS to review the data. And in this case, I'm looking at part numbers, and the columns represent the different processes. So I have a module that is tested in installation, pre-burn-in, burn-in, and final function test. And then I have some subunits inside of that module, all of them tested in PCBA test, one of them tested in ICT test. And for today's session, I'm going to go through this heat map from left to right and show some examples of different ways you can use the test step analysis to do root cause analysis. So the first thing I'll do, I'll start on the left-hand side with this part number tested in PCBA test. You can see that it's one of the worst yields. You can see that from the red colors and also from the yield metric. So we have an 88% first pass yield. And in this process heat map, I can also see the stations, I can see the repairs, but I can also see the most frequent issues. So these are the 10 most frequent issues with this product in this process. And you can see how many times it has failed. And you can also see by the orange and red colors and also blue if they are error, failed, or blue is terminated. So the first thing I'll do, I will just use this issues list, and I will pick one of the top issues and go directly to that step to analyze the content of that step. So I will skip the first one since this is a string value step. It's reading the software part number, and all the failures are also errors, which indicate that these are a test equipment problem. And I would rather look at numeric measurements. So we'll skip the first one and go to this one. And I'll simply click the step to open the step details. And once the step details view opens, it has a lot of menu items on the left-hand side, and it also has a lot of different charts in the first view, which is called the overview. I'm going to mainly focus on this top part today, which is also the most important part, and then briefly explain what the other parts are. So the first thing you need to understand about this report is that there is an aggregated view, and then there are actual measurement views. So the first one on top here is always based on aggregated data. That means whenever WATS receives a report, we aggregate down to the hour what is the lowest measurement, what's the highest measurement, what's the average, and what's the CPK, and so on. And this is really useful when analyzing big data, because we can analyze millions of units more efficiently than looking at the individual measurements. So in this case, this view is set up by default to look at days. So I can see every day with production here. And the red bar shows me the failures. I can also see the total number of runs. So now the blue grayish one tells me how many runs there are, and the red one shows the number of failures. And then I can see the CPK value in yellow. So you can see that drops when failures occur, and then it rises again when the failures go away, and it drops again when the failures occur here. So one thing you can do, which is really useful for this chart, is now that we have opened it, I can see immediately that in this green area, which is the area we are evaluating down here, so the measurements here represents the measurements inside the green area. It might make sense to do like this, because I want to catch these errors as well. And I can also, of course, extend it. And you can see now there's 2,600 units, and I apply the selection, and that will update my view. So that's kind of the first thing you need to master to be able to use this report. And now you can see all these failures are suddenly visible that occurred on the 18th and 19th and 20th of March. And in this aggregated view, I can see the low and high limit. I can see all the failures are to the low limit. And I can also see that this seems to be a problem that was fixed at March 20th, and it is no longer a problem. Might be that it's reoccurred here at the 25th of March as well. But what I want to show you first in this view is this yellow button, which is the WATS Alvea button for the step details. And this works the same way as the WATS Alvea button in the process heat map. The difference is that this one works on this step only. And what it will do, it will process all the reports and look for deviations, look for something that can explain these failures, and it will show us some suggestions. So I click this one, and you can see immediately that I get 4 different suggestions, and these are ordered by importance. So the fixture ID on top is most likely the most pressing correlation found here. So clicking the fixture ID, I will now split this data based on fixture, and I can see the different fixtures in different parts of this chart. And I can see that almost all the failures are related to fixture number 71. So already at this point, we have a pretty good feeling of what the root cause is. At least we know it's most likely a test equipment issue. It's most likely something to do with the fixture pins or maintenance or something like that. Oops, that was not my intention. So, and before I move on to the next step, I also want to show you a hidden feature in WATS. Sometimes zooming in these different charts can be a little bit struggling to find the exact thing you're looking for. So if you hold the Alt key, you can box select what you want to look at, and that will zoom into that area. So that's really helpful if you want to narrow down to the details. Okay, I will leave this step for now. Simply close it down, go back to the process heat map, and I want to do the same thing again. I could go to the next step on the list, which is a multiple step with a frequency and a peak-to-peak voltage test. But instead, I will do something different. I will go through the test step analysis report. And in general, you could say that when I click this one, this top issues list, it's based on everything from this part number. But there might be hidden deviations in this part number that will cause deviations in your data as well. For instance, there might be different product revisions running here. There might be different versions of the software running, and all these things can also greatly affect the results. So if you want to have more control of what you're actually looking at, instead of going directly in here, I go to the drill down menu, and then I find the test step analysis report in the list, and I drill into that one. And this is an intermediate step before we get into the step details. And in this report, you will see that it will list the different combinations of softwares and product softwares and test softwares. So in this case, it's a 159 and 160, and they're all tested on the same part number and on the same part revision. So when I'm here, I can choose to look at one of these, or I can choose to look at them all. And if I look at them all, they will be merged into one sequence. So it will, of course, depend on how similar they are. If they are more or less the same, that makes sense. So I apply the selection, and that will load the actual sequence. So this test step analysis report is where you analyze the sequence as one to try to figure out which steps to look into. And this test step analysis report first has the step list with all the steps from the sequence and KPIs for the data set as a whole. So I have CPKs, I have plus and minus 3 sigma, I have a variance and standard deviation and all these kind of things that can be used to find deviations as well. So I can sort and filter this list to find whatever I want to find. I also have Alvea suggestion here. So this one indicates that there are outliers in the data. So although there's a 9.3 CPK, never failing step, there are samples that are close to the limits and that might cause issues down the road. Scrolling further down in this report, I have 4 Paretos. I'm not going to spend a lot of time with these, but this is the same list that we looked at in the process heat map, the top failures. And then I have the same thing for worst CPKs. So this is the worst CPK, a negative CPK, and it's a step that doesn't seem to fail. So this is a little bit strange. Maybe we should have a look at that. And then I have 2 Paretos that is based on step time. So this is the top 10 steps by average step time. So how long time they take. And this is the same thing, but excluded all the failures. So even when a unit runs with no failures, the boost step is the most time consuming with a maximum step time of 5 minutes, which might be a problem, at least inefficient in some cases. So if you want to investigate any of these steps, you can click the bar, and you can also check more than one step here and use this analyze selected to open them all, or I can open the magnifying glass directly from this line to open the step. So in this case, I will go to the top 10 steps, and I will select the 4th one on the list, measure T101 voltage. Go to the step details. Press the WATS Alvea button, and in this case, I get the first suggestion is subunit, part number and revision. And this is a new feature in WATS that this wasn't supported before. So what we do here is that we'll look at the connected subunits for the unit we are looking into, and we're comparing the part number and revision for it to see if there's some difference. And here I can see that for most of the tests, there is this part number and this revision. But for some of these tests, and also the ones that are failing, there is no subunit logged. So that might be an indication of a problem with this one. Before I move on, I will also want to show you a couple of other things in this overview. So let me just remove the subunit and look at operator, for instance. It will show me one graph for each of the operators. Scrolling further down, I can see that I have the same data set as a moving range. So it's the same data, just another visualization. And then I have a box plot as well. So this box plot will show me one box for each of the operators. And I can see it's a little bit hard to see here because we have outliers far off the normal distribution. But I can use the Alt key here again and mark what I want to look at. And I can see the distribution across the different operators. So the box plot is also really useful when you have a lot of series. So if you're looking at sockets and you have 60 socket indexes, it might be hard to read from the individual chart and easier to read from the box plot. And there are also some other features down here. We have a QSUM, XBAR, and a range chart. Okay, I will go back up and I will close this one, and I will close the test step analysis as well. And then I will go back to the process heat map, and let's say that we are done with the PCBA tests. I will go to the next one, the ICT test. So I will do the same thing here. I can go to the test step analysis report, but in this case, I will do the detour, the shortcut, and go to the most frequently failing step of the ICT test. And this is NTC 101. So these are typically component references that are failing. I'll click this step, and that will take me back into the step details. I want to look at everything, apply the selection. And in this case, I can see immediately that we have some failures that are really far out from the normal distribution. It's even hard to see. So if I do the control selection again, you can see that when I zoom in, the normal distribution is between these narrow limits. Since the failures are so far off, it's really hard to see. So this is typically a case where the workbench is useful. I could, of course, use the WATS Alvea. It would probably detect my problems, but in this case, I can use this open the workbench, or I can use this icon on the side workbench. So I'll go here, and the workbench is essentially a one-page view of the actual measurements. It has some more tools, and it has some more space, so it's a little bit easier when you are reviewing data that is where you want to have a closer look at the details. So what I can do here now is that in this view, I have these boxes over here. So I have the ability to adjust the limits, and I can also filter measurements based on the max and min values. And you can see here that the maximum value is 58,000, but the high limit is 120. So I can go in here, and I can say that if I set this to 150, then I filter out all these measurements that are far off the normal distribution, and I can zoom in on the rest. And then you can see that there are actually a lot of failures to the low limit as well. If I click the Alvea now, it still says operator. Let me see. Filter by operator. And yeah, it seems like it's failing more or less across all operators, but some of them not. So I have one here with 0 failures, and that is probably what is triggering the suggestion on operator. But let's look at this one as well, MISC-info hardware configuration. Do the same thing. I'll zoom in, and then I can see that in the hardware configuration 3.0.1a, the distribution is a lot lower and failing a lot more frequently. The reason Alvea doesn't pick up on this in this case is that this problem has just started, and the number of units accounting for this is very small compared to the entire data set. So probably the percentage just doesn't reach up. But if once more measurements comes in here, WATS Alvea will also catch up on this one. Also, a new feature in the test step analysis workbench is this statistics view. So now you can look at the statistics for these measurements, such as CPK, CP, standard deviations, and variance. And this will recalculate as you change your limits and change your filtering. So if I reduce the high limit, I will see the CPK and KPIs in general recalculate to that limit. So that might be useful in your process capability analysis if you want to see what does this look like if I discard some measurements and so on. Okay, I will close this one, go back to the heat map, and before I move on, if there are any questions, I'll do it. We might do some now.
No questions so far, Ola.
Great. Then I will just go ahead. Time is flying, so I will have plenty enough to talk about. Okay, I'll close the ITT test as well, and we'll move on to the installation test. Same thing here. Two failed steps. They are both multi-step, so there are two readings for each step. It's a current and a pass-fail reading. I'll simply choose the current one. I'll use the aggregated view to pick up everything, and I'll use Alvea. And this one says station name. And I can see immediately that all the failures are related to that station. Can go to the workbench. Another feature of the workbench that is really useful for looking at big data is, so now we're looking at actual measurements, meaning that we're looking at the green area here, which are 2,931 units, which is nothing. So that's not a problem. But once we get units in the counts of millions or hundreds of thousands, it's going to be very slow to load the individual measurements. So that's why we have this type selector in the workbench. So I can choose to select aggregated measurements instead of individuals. And that will simply use the data warehouse, use the minimum and maximum and average readings, number of failures, and so on, to do the same analysis in general. So now we're looking at station name. Every station gets its own chart, and we're looking at this over days. So every dot on this chart represents a day, so we can see the trend of the CPK dropping here. I can also include the failures, so you can see the failures are starting to occur once the CPK drops. And then I can see the same thing for the other stations. So this is a view where you can effectively use WATS Alvea on hundreds of thousands of units without timing out. Perfect. Then I'll go back one more time. We'll close the installation test, and now we only have the pre-burn-in and the burn-in and the final function test. I will not be looking at the burn-in test today, but we want to look at the pre-burn-in test and the final function test. This is a special setup for one of our customers that we have used for demo purposes. And what they really do here is that they run their functional tests before they do burn-in. So this is simply a precaution to make sure that they don't send a faulty unit into a 24 or 48 hour burn-in test. It will be very costly. So they run the functional test first, catch any failures, and then if they pass, they go through the burn-in, and then they run the final function test again, which is essentially a copy of this one. So looking at the issues here, I'll see that the top one is position 1 empty. It's a true-false step. But in this case, let's look at it. So you'll have an example of what a true-false step looks at as well. So the true-false step will only show two different values, either pass or fail. So it's a binary chart. So the chart itself doesn't give you that much information, but Alvea can still do the calculations based on what's found and what's in the data sets. So here I can find subunits, part number, and revision. I can also find the fixture ID. But the point of this was to show you, if you want to, in this case, look at, can I compare the results of my pre-burn-in functional test with the post-burn-in functional test to see if there are any differences? And yes, you can. And in that case, I want to go through the test step analysis, so I'll just choose one of them. Go to the test step analysis report. And in the filter, I will go up to the test operation, and I will add the final function test. And then I apply. And then you will see that these sequences are actually identical. It's the same sequence run both before and after pre-burn-in. We're looking at same revision, same software version. So if I apply now, I essentially get the same sequence, but I get double the number of runs, because it's run first in pre-burn-in and then in final function test. I can now go to any of my charts, view in step details. Do everything. And now I can go to my grouping and I can choose test operation as grouping option. And then I can see the pre-burn-in results side by side with the final function results. I can also go to the chart options and switch from group to measurement. It will overlay those two measurements. So I can see how they correlate. Can of course still use the zoom to see if there are any correlation in the data set. Excellent. Any questions at this point, Haldor?
No more questions.
No more questions. Okay, excellent. Then I will just go all the way back again, and I will open a step to show you a couple of other features that are available in the test step in the step details view. So I'll just do the first numerical one that is failing here. Load it into this view. And now from this menu on the left-hand side, the top one selection is the step list. So clicking this will open the same step list with all the available steps. So from here, I can add in second and third steps, click the Analyze Selected button, and that will load these steps on top of the other ones. So now I can see 3 steps side by side. I can also switch to group and see them overlaid. And I can go into this one, not the workbench, but the next one with the A and B, which is called step comparison, which opens an XY plot with one measurement in the x-axis and one measurement in the y-axis. I can also apply the grouping. So let's say I want to look at how this is across station names. And then I can see the distributions for the different stations. I can see the green one seems to be a little bit lower than the red one and so on. The next menu item is called a step chart, and this step doesn't have a chart, but the idea is that a single step in WATS can be a single measurement, but it can also be chart data. So you can have a frequency chart that is one single step. And when you can have those charts overlaid to see how the failed charts are displaying compared to the past ones. And the last menu option on this view is the data view. So if you want to export or manually do any filtering and exploration of these steps, you can click this. It will show all the steps in a grid where you can filter, sort, and export if you want this into Excel or MATLAB or something to do other calculations. Perfect. I think our time is up, and I roughly got through what I wanted to. So if there are no questions still, I think that will be the end of this session. Thank you all for listening, and good luck exploring the test step analysis and WATS in general.